All right, so in section 9.4, part 3, we are dividing rational expressions now. So before we do that, we're just going to remind ourselves how we divide fractions. So we've already written here when dividing fractions, we keep the first fraction, change the sign to multiplication, and flip the second fraction. So for part A, we have 1/2 divided by 2. So step 1 is we want to make that a fraction, that whole number. So now it's 2 over 1. So we keep first fraction, change it to multiplication, flip the second fraction. And then it's just a multiplication problem now. So you multiply across the numerators and you multiply across the denominators, and that's it. For the second one, we have 2 over 7. Change it to multiplication, then flip the second one. Multiply across the numerators, 2 times 3 is 6. Multiply across the denominator, 7 times 4 is 28. And then as always, reduce if we can. So this we can reduce by 2 because those are both even. So we'll get 3 over 14, and that's it. So this last one, we want to write that 5 as a fraction. So it's 5 over 1. And then we keep, change, flip. So we're multiplying it by the reciprocal here. So 5 times 11 is 55. 1 times 9 is 9. That's it. So that same rule applies when we're dealing with rational expressions. So if we're going to divide this rational expression, we keep the first fraction. So 5x over 3x minus 12 stays the same. We change the division to multiplication, and then we take the reciprocal of the second fraction. So we flip the second fraction. So now it's x squared minus 6x plus 8 over x squared minus 2x. And now that we've done this, it's just a multiplication problem. So we just treat it like we did with those multiplication problems in the last part of this section. So we group the polynomials to keep them together. And then we have 5x times x squared minus 6x plus 8 over 3x minus 12 times x squared minus 2x. And now we factor. So the 5x is a monomial, so we don't need to do anything to that. This is a trinomial, so we're going to factor it by asking ourselves what adds to -6 that multiplies to 8. And the answer to that is -4 and 2. Sorry, -4 and -2, I should say. Because -4 plus -2 is -6, and -4 times -2 is 8. Then in the denominator, for this first polynomial, 3x minus 12, we have a GCF of 3, so we can factor 3 out. And then we're left with, so if we take the 3 out of the 3x, we're left with x. And if we take a 3 out of a 12, we're left with 4, because 3 times 4 is 12. So now this last one, we're going to think about a GCF again, because these both have x's in them, in their terms. So I'm going to take one x out. And if I take an x out of the x squared, I'm left over with 1x. And if I take an x out of a 2x, I'm left with 2. So then simplifying this further, I'm going to cross that out so we don't get confused. We're going up here. In the numerator, we have 5x, x minus 4, x minus 2. In the denominator, now I like to put my monomials together in the front. So we have 3 times x gives us 3x, x minus 4, x minus 2. So when we write it like this, it's pretty easy to see. Well, the 5 and the 3, those don't cancel at all. But we have an x here, and we have an x here. Those are factors because this is all multiplication. It's 5 times 3 times x minus 4. So we can cancel those x's out. We also have a like factor of x minus 4 and a like factor of x minus 2. So now we've canceled everything out, and we're just left with 5 over 3. So that's it with dividing rational expressions. You just have to do keep, change, flip, also known as multiplying by the reciprocal, and then treat it like it's a multiplication problem. So as always, if you got lost along the way somewhere there, you should definitely go back up in the video. That's what the videos are here for. To make sure you really understand what's going on. Maybe pause it when I'm doing it to think about where each step comes from. And let's do the next one. So now we're doing part B, so we'll cross out A so we don't get confused. So we're doing B now. So we have first fraction is 3x squared plus x minus 2 over x squared plus 3x plus 2 times x plus 2 over 2x. So we did keep change flip. Now we're going to group everything together and multiply across the numerators to get 3x squared plus x minus 2 times x plus 2 over, I'm going to put this 2x in front, if that's okay with you, just because it's a monomial and I like the monomials in front. So 2x I'm going to put in front of this, and then we have 2x times x squared plus 3x plus 2. All right, so something a little funny here. We have a trinomial here where a is greater than 1. So we have a 3 here. Now, in this section, I'm not going to ask you to do this for now, but I do want to quickly go over how we factor this because you're going to need it for your final. So let's quickly talk about box method. So this is what we're factoring here. I've set up the box here. We make our little window. We put our first term here. We put our last term here. We need to figure out what a times c is. So a is 3, c is -2, and b is 1. So, oops, that should be a -2. So a times c is -6 and b is 1. So we need to know what multiplies to -6 that adds to 1. Well, fortunately, we kind of already have our answer here because 3 times -2 equals -6 and 3 plus -2 equals 1. So those are our numbers here. So those numbers, 3 and -2, those go here. 3x, -2x. And remember, it doesn't matter which goes where because it'll work out the same way. And then we go up our columns and we find a GCF. So we have 3x and -2. Those do not have a GCF other than 1. So we just put a +1. And then we have 3x squared and -2x. The only thing those have in common is an x. So we just put an x here. Now going sideways, so horizontally, we have 3 and 3, so GCF of 3, and we've got x squared and x, so we can take one x out of that. And then down here, this first one is negative, so that means this is negative. We've got a 2 and a 2, and that's it, because only one of those has an x. So then our two factors are 3x minus 2, x plus 1. So we have now factored that. So when we rewrite this, we will have 3x minus 2 times x plus 1, and then times x plus 2 in the numerator over 2x. Now this is just regular factoring. So we just ask ourselves what adds to 3 that multiplies to 2, and that's x plus 2, x plus 1, because 2 plus 1 is 3, 2 times 1 is 2. Reason you just do regular factoring is because there's no number here in front of the x squared. We had to do the box method here because there was a number there. So now that we've factored everything, we can see what we can cancel. So for this, we've got a 3x minus 2 in the numerator. I do not see that anywhere in the denominator. Move on to the next one. We've got an x plus 1, and we do have an x plus 1 in the denominator, so we can cancel those out. And then we have an x plus 2 and an x plus 2 in the denominator. So then finally, we're left with, in the numerator, 3x minus 2, and in the denominator, 2x. And that's it. So we've got 2 more examples. This time we're dividing by a polynomial. So the only thing that's different about this is that you need to put this over 1. That's it. So now that we've done that, it's the same type of problem. So you do keep change flip because it's division. So 6x squared plus 7x minus 3 over 6x squared. Keep the first fraction, change to multiplication, and flip the second fraction. All right, and now we multiply across the numerators. So we've got 6x squared plus 7x minus 3 times 1. So we don't really need to write the times 1 over 6x squared times 2x squared plus 3x. All right, and now we need to factor. So this is another trinomial where we have a number in front, which means we are going to do the box method. So I've already got it set up here. So here's our box. Put the first term here, put the last term here. We need to figure out what a times c is. A is 6, c is negative 3, which is negative 18, and b is 7. So we want to know what what multiplies to negative 18, that adds to 7. And we've already figured out here that it's negative 9 and 2, because negative 9 times 2 is negative 18, negative 9 plus 2. That's actually a mistake, ladies and gentlemen. It should be the other way around, shouldn't it? All right, so it's 9 and negative 2, actually. So 9 and negative 2. Okay, that's better. So 9 times negative 2 is negative 18. 9 plus negative 2 is positive 7. So let's put 9x here, negative 2x here. And now let's go vertically and find our GCFs. So we have a 9x and a negative 3. We can take a GCF of 3 out of those. And it's positive because this top box is positive. Then we have 6x squared and negative 2x. So 2 goes into both 6 and negative 2. So I can take out a 2, and then we have an x squared and an x. So I'll take out an x. And then if I'm going horizontally, we have 6x squared and 9x. I can take a 3 out of both of those and an x. And then down here, this first box is negative, so this is going to be negative. And the only thing I can take out of that is a 1. So our factors are 3x minus 1 times 2x plus 3. And then if we go back, we just figured out that our numerator is 3x minus 1, 2x plus 3. Then in the denominator, we have 6x squared. And then for this polynomial here, all we can do is a GCF. So these both have x's in them. We have an x squared and an x to the first, which means I can take out an x to the first. And I'm left with 2x plus 3. All right, so just simplifying a bit, we've got 3x minus 1, 2x plus 3 in the numerator. In the denominator, we have x squared times x to the first. So I'm going to write 6x cubed times 2x plus 3. Then we see what we can cancel. So 3x minus 1, I don't have one of those in the denominator, but I do have a 2x plus 3. And that's all we got. So we're left with 3x minus 1 over 6x cubed. And that's it for part A. So let's move on to part B. Last one in this whole section. Actually, this is the last set of notes we're doing all year. So this is the last example for the year. So for letter B here, we're going to do keep, change, flip, like that. And then we will factor. So this first polynomial, oh, actually, I forgot to multiply everything together. So we did keep, change, flip. Now we multiply the two fractions. So this guy times 1, you don't need to write the 1. Then we have x squared minus 6x times 3x minus 24. Now we can factor. So in the numerator, we want to know what adds to negative 14. That multiplies to 48, positive 48. And that's going to be negative 8 and negative 6. And then in the denominator, this first polynomial here, I can take a GCF out of that. So we have an x squared and an x. So I will factor out an x. Then I'm left with x minus 6. And then in this second polynomial, I can factor a GCF out because 3 goes into both 3 and 24. So I can factor out a 3, and I'm left with x minus 8. All right. So then what I like to do next is I like all the monomials in front, and in the denominator we have 2 of those. We have an x and we have a 3, so I want that 3 out in front because it's a coefficient. So 3x, x minus 6, x minus 8. So then when we're canceling, we've got an x minus 8 in the top. We've also got a factor of x minus 8 in the bottom. We've got a factor of x minus 6 in the top and a factor of x minus 6 in the bottom. Now, even though we canceled everything out in the numerator, there's still an invisible times 1 up there. You still need a numerator. You can't get rid of the numerator. It doesn't work like that. So you need to keep a 1 in the numerator and then a 3x in the denominator. And then we are done. So that is it for section 9.4 on simplifying, multiplying, and dividing polynomials.